My name's Nikki.
And I'm Soraya, and together we are going to talk to you about nutritional epidemiology, why it is relevant, and ways that you can source and determine the reliability of nutrition-related information. But first, let's ask the question, what is nutritional epidemiology? Also known as the science of public health nutrition, nutritional epidemiology is the study of how diet affects health and diseases within a population. Over the last few hundred years, findings from epidemiological studies have played an important role in the creation of guidelines that have helped to prevent disease and improve the health of a population. For example, it was identified that inadequate intake of folate in the first few weeks of pregnancy increased the incidence of neural tube defects in newborns. As recommended levels of folate were difficult to acquire from the diet, mandatory or compulsory fortification of wheat flour with folic acid was introduced. Since then, the incidence of neural tube defects has decreased by 74% and 14% amongst Indigenous and non-Indigenous females respectively within Australia. The NHMRC's Australian Dietary Guidelines were developed based on various epidemiological studies and provides Australians with dietary recommendations to eat for health. A key way in which nutritional epidemiologists are able to understand how diet impacts on our health is through analysing the relationships between exposures and outcomes. Within epidemiological studies, the exposure refers to any characteristic that may explain or predict the presence of a study outcome. Some examples of exposures within nutritional epidemiology may include, but are not limited to, the types of food an individual consumes, called a dietary pattern, the amount of a particular food or food group consumed, alcohol use, and body measurements, such as waist circumference, hip-to-waist ratio, or body mass index. These are typically measured in a number of ways, including weighed food records, 24-hour dietary recalls, and food frequency questionnaires. In a weighed food record, participants record everything that they eat and drink over a period of several days or weeks. The advantages of this method are that it is more accurate, as there is no reliance on memory. It also provides more accurate information about portion sizes and therefore nutrient intake. However, the disadvantages of this method are that it places a high burden on participants. The process of recording can also cause an individual to change their diet. Lastly, it is expensive and requires a lot of resources. In 24-hour dietary recalls, participants, with the aid of an interviewer, record all foods consumed within the previous 24-hour period. An advantage of this method is that it is relatively accurate, as it does not rely on long-term memory. There's also a low participant burden and it is inexpensive to administer. A disadvantage of this method is that the reliance on memory may cause recall error by leaving foods out or incorrect portion size estimation. Participants' dietary data may also differ based on the timing of the recall, for example, weekday versus weekend. And finally, in food frequency questionnaires, participants complete a survey consisting of a list of foods and the frequency that they consume them over a period of time, for example, 1 year. The advantages of this method are that it can be used to assess past dietary intake. It is also inexpensive, easy to administer, and there is a low participant burden. However, disadvantages are that there is large potential for error due to the reliance on long-term memory. Intake of foods may be missed if it does not appear on the questionnaire, and it must also be culturally and population specific. An outcome is the characteristic that is predicted to change in response to the exposure. Some examples of common outcomes measured within nutritional epidemiology may include, but are not limited to, death, mortality, the presence of a disease, morbidity, external body measurements such as the ones mentioned earlier, or internal ones such as blood pressure or blood cholesterol. Here are some examples of common exposure outcome relationships. Foods commonly consumed as a part of a Mediterranean-style diet, such as fish, nuts and oils, fruits and vegetables, the exposure, have been associated with a reduced risk of cardiovascular disease, the outcome. In contrast, higher intakes of trans fats, the exposure, is associated with increased LDL or bad cholesterol and reduced HDL, good cholesterol, being the outcome. And finally, increased intake of red meat is associated with an increased risk of colorectal cancer. With the development of the internet, print and social media, nutrition information is able to be distributed far more widely and easily than ever before. Unfortunately, this has made it more difficult to locate relevant and accurate information, which increases the importance of being able to differentiate between fact and fiction. Available in academic magazines, journal articles, or research papers, are often reviewed by other experts in the same field before being published. However, the methods used when conducting their research, called a study design, can impact the strength of their findings, also called evidence. To help grade this evidence, the National Health and Medical Research Council have developed what is called the hierarchy of evidence. In essence, the higher the study design on the hierarchy, the more reliable the results are. Now, Nikki is going to explain the different study designs that can be used in epidemiological studies.
Ecological study is a type of observational study that is generally used to illustrate the association between exposures and outcomes. It might sit at the bottom of the pyramid, but it is a practical method to generate hypotheses for further investigation. It is also used for researching rare diseases, considering a large sample size is usually warranted. When reading conclusions from ecological studies, the readers should be aware that the result is not appropriate to be applied to individuals. For example, meat products from higher altitude have a different fatty acid profile. Hence, the result should not be applicable to individuals from lowland. Cross-sectional study can be understood as a snapshot of the exposures and outcomes at a particular time. Similar to ecological studies, it does not intend to answer specific questions. Rather, it provides some insights towards the interest of study to generate in-depth research questions. It is a cheap and fast method to conduct a study to measure prevalence without loss of follow-ups. However, it should not be used to establish causal relationships between the exposures and outcomes. For instance, if low-fiber diets and occurrence of obesity are measured at the same time, it would be difficult determining which one causes the other. Case control study can be considered as a step further for hypothesis testing. As what is indicated in the name of the study, the purpose is to compare the exposures of the case and control groups. Recruiting appropriate control is challenging. The result may be affected if controls are volunteered, as they may generally be more health conscious. This study design is susceptible to all the common biases mentioned in the next section, especially in the absence of blinding. In cohort studies, subjects are followed and recorded for the development of disease. It is the only observational study which provides direct measurement of risk factors to indicate causes of a disease. It commonly requires a large sample size, usually over 10,000, and there can be loss of follow-ups. Hence, it is not a suitable study design for diseases with late onset or rarity. On the other hand, the data collected from cohort studies tends to be accurate and detailed, therefore can be used for other interests of research. Given the organic nature of the study, sometimes unexpected outcomes can be revealed from following the cohorts. Non-randomized experimental study is largely used in hypothesis testing in pilot programs. Pilot programs are essentially conducted with the purpose of determining whether an intervention should be applied and how practical it is. It is commonly used in government policy making. Experiments are performed with investigators allocating the treatment in a non-randomized manner. This type of experimental study can be prone to biases, especially allocation bias and confounding. Randomized controlled trials apply manipulation of the risk factors to the control and treatment groups to generate results for comparison. Researchers are expected to ensure a 50% chance for all participants to be allocated to either groups without revealing the treatments. There is less chance for assessor bias and recall bias to occur if the experiment is blinded to both assessors and subjects. It is said to be the most reliable study design, the gold standard for medical testing. However, in terms of nutritional epidemiology, it can be tricky. For example, in most of the drug testing, participants can be successfully blinded towards the treatment as everything is packed into a pill, while dietary intervention is usually in the form of food. Participants are likely to report based on pre-existing knowledge about the food. Observational studies tend to let the condition develop without any interventions, while experimental studies rely on intervention to establish a causal relationship. Although randomized controlled trials may be more reliable, cohort studies seem to be a popular choice among nutritional epidemiologists for a few reasons. For example, it is unethical to prescribe harmful dietary interventions. Randomized controlled trials with strict dietary interventions often report high dropout rate or low compliance, which can significantly affect the accuracy of the outcome. In contrast, cohort studies have a much larger sample size and longer follow-up time, which, in a context of nutritional epidemiology, generates more informative results suitable for generalization to the public. When reading studies, it is helpful to be aware there are a few common sources of biases to which certain studies are more susceptible. Selection bias occurs when selected participants have characteristics that are different from the population. For example, more health-conscious people are more likely to participate in researches. Therefore, the results may not truly be representative of the public. Another example is that some diseases make the desired subjects unavailable to participate, for example, if they're frail or if they die. Case control studies and cohort studies are particularly prone to this type of bias. Recall bias and observer bias are also frequently reported during data collection and measurement. Studies rely on self-reporting are prone to recall bias because the participants have various levels of memory and ability to estimate or measure. Moreover, it is common to see participants underreport consumptions of perceived unhealthy food. Observer bias comes from inconsistency in questioning, especially when researchers know who belongs to control or case groups. Another source of bias is confounding, which refers to the variables associated with both exposures and outcomes and may induce a false positive causal relationship between them. For example, alcohol consumption and heart diseases are the exposure and the outcome respectively in a study. But smoking can act as a confounder in this scenario and affect the results, particularly in observational study designs.
Journal articles, which Nikki has just discussed, are typically found in databases such as PubMed or Medline, but subscriptions to these can be expensive. However, similar literature can also be accessed at no cost via Google Scholar. Understandably, journal articles can also be difficult to digest, but caution needs to be taken when sourcing nutrition information online. When assessing the reliability of online information, try asking the following questions. The more times that you answer yes, the greater the likelihood that you have found a web page with high quality information. Accuracy. Has the name of the author or the institution that wrote the article been provided? And does the article include the author's contact details? Authority. Are the author's credentials listed and are they relevant? And is the page from a preferred domain? Objectivity. Does the page have limited advertising? And does the author present the information in an objective way that is free from bias or opinion? Currency. Is the page current and does it appear to be updated regularly? If it includes links, are these up to date? Coverage. Can you view the information properly? Is it not limited to fees, browser technology, or software requirements? As mentioned above, the website domain can provide insight as to who has written the article and therefore how reliable it is. For example, .com indicates that it is a commercial site, which means that the website exists for the purpose of selling a product or service. As businesses are likely to portray the product or service in a positive light rather than remaining objective, it is important to analyse the information being provided critically. .edu indicates that it is an educational institution. However, these sites can be used for schools as well as students' personal websites. Unless it is from a department or research centre from an educational institution, it is important that information be analysed critically. .gov indicates that it is a government website, which is regarded as a credible source of information. .org indicates that it is a non-profit organisation. While some organisations will represent information objectively, some will exist for commercial reasons, so it's important that the information be viewed critically. .net generally can be used for anything that does not fit into the other domain suffixes, therefore should be analysed critically. Please note that this is just a guide, and if you're in doubt, refer to the questions that were provided earlier. Here is a list of government and non-government organisations and their websites that provide reliable, evidence-based nutritional information. These include the National Health and Medical Research Council, NHMRC, the Australian Institute of Health and Welfare, AIHW, the World Health Organization, or WHO, the Heart Foundation, Diabetes Australia, and the Dietetics Association of Australia.